Have you ever considered the true cost of a single delivery truck just breaking down on the side of the road?
Oh, most people definitely don't.
Right. And I don't just mean the cost of, like, a new alternator or calling a tow truck. I mean the real cascading cost of the entire system.
Yeah, exactly. Because most of us, we only see our own delayed package notification. We don't really see the massive chain reactions spreading out from that one stranded vehicle.
Exactly. It's lost technician hours, it's rescheduled jobs for dozens of other stops, overtime labor kicking in just to catch up. A single breakdown causes this localized failure across a really massive, highly calibrated network.
Right.
You, as the customer, just get a text message. But behind the scenes, logistics operators are basically scrambling to reroute an entire city grid. So welcome to today's deep dive.
Glad to be here.
Our mission today is to really decode this invisible logistical ecosystem that gets packages to your door, keeps cities running, and is currently undergoing a totally unseen revolution. The traditional gas station model, as we know it, is dying.
It really is. I mean, the physical infrastructure we've relied on for over a century is just fundamentally incompatible with where logistics are heading now. We are literally watching a complete dismantling of the centralized fueling model.
It's wild. And we're pulling from a deep stack of industry reports today to sort of chart this out. We are looking at hardware insights from VMAC and GM Fleet, software and infrastructure data from Comerit and ADS Tech Energy, and mobile power reports from ZAP EME, ESFIL, and SparkCharge.
Lots of ground to cover.
Yeah, we're covering the vehicles, the grid, the software, and the economics.
Okay, let's unpack this starting at the micro level, the actual trucks on the road. Historically, upfitting a service truck was, well, about as crude as finding an empty metal box and just throwing a bunch of separate heavy tools into the back.
Oh, entirely. The traditional approach was completely fragmented. If an operator needed compressed air, they'd bolt a standalone generator and a really heavy air compressor to the truck bed.
Just taking up all that space. Exactly. And then if they needed to weld, they bolted a separate welder next to it. Need to jumpstart heavy equipment. That required an isolated battery booster. Every single tool had its own engine, its own fuel source, and its own maintenance schedule.
So, I don't know, it's like trying to run a modern data center using 50 separate AA batteries instead of a unified power supply.
That is a great way to put it.
Because every time you bolt a new independent machine onto that truck bed, you're adding hundreds of pounds of unnecessary weight. You're creating this chaotic mess of wiring. And worst of all, you're adding a brand new point of mechanical failure.
Right, and what's fascinating here is the paradigm shift in how fleet managers actually view these vehicles now. We see this super clearly in the reports from VMAC. Operators are realizing that fleet productivity is no longer a tool problem, it is an ecosystem problem.
An ecosystem problem.
Wow. Exactly. For decades, the industry just asked, what tools should we bolt onto this truck? But today, the only metric that matters is system-wide uptime. They're asking, how does this vehicle operate as a single unified power platform?
Uptime is the entire game. And to maximize it, companies like VMA are pioneering these integrated mobile power systems that turn trucks into highly efficient unified platforms. Take their underhood air compressors, for example.
Oh, yeah, those are brilliant.
Right. Instead of taking up cargo space with a giant standalone unit, they integrate the compressor directly into the truck's existing engine compartment. It just runs off the vehicle's own belt drive.
Which is huge for weight saving.
Exactly. It drastically reduces the gross vehicle weight, frees up cargo space for actual payload, and just simplifies the whole mechanical architecture.
And they take that integration even further with systems like their 6-in-1 multifunction power system.
Wait, 6-in-1?
Yeah, so instead of idling a massive diesel V8 engine just to run one small tool, this is a single platform powered by a really compact integrated engine. It gives the operator a welder, a generator, an air compressor, a battery booster, and a hydraulic pump, all in one.
Wow.
And the best part is the operator can actually turn off the main truck engine, which eliminates unnecessary emissions and wear while still having all that power totally on demand.
That makes so much sense. Buzz Kirby from the city of Livonia in Michigan is actually quoted in our sources talking about this exact setup. He points out that with an integrated system, there is no lost time traveling back to the municipal yard to grab a tow-behind compressor.
The travel time alone is a massive drain.
Yeah, you eliminate the travel time and you eliminate the liability of towing a trailer through city traffic. The truck arrives and the power is instantly ready.
But, if we recognize that the service truck is now this highly integrated power platform, that kind of forces us to look at the next massive logistical hurdle.
Well,
The energy source powering that platform, it's shifting entirely away from internal combustion.
oh, right, which brings us to electrification.
Yeah,
And honestly, this is where the industry seems to hit a massive physical brick wall.
it really does. The push to electrify is aggressive, mostly driven by intense environmental urgency. I mean, last mile logistics account for roughly half of all delivery vehicle CO2 emissions.
Half. That's insane.
Yeah. So major players are moving fast. FedEx is committing to an entirely zero emission EV delivery fleet by 2040. Amazon is rolling out 100,000 electric vans. GM Fleet has engineered the 2025 Bright Drop van specifically for this ecosystem. It offers a 272-mile range and can accept 180 miles of charge in just 1 hour.
And the data shows this shift actually yields measurable public health results, right?
Yeah.
Look at London's ultra-low emission zone, the ULEZ. By prioritizing zero-emission vehicles in the city center, they achieved a 53% drop in nitrogen dioxide levels.
Cleaner air, less noise pollution.
Exactly. But according to the 2025 State of the Mobile Compressed Air Report, fleet managers are still incredibly skeptical. They are worried about range, battery chemistry in sub-zero temperatures, and, like, most critically, they're worried about the physical limits of the electrical grid.
The grid bottleneck is easily the defining infrastructure challenge of the decade. The sources include this stark anecdote from Germany that illustrates this perfectly.
Oh, the Oranienburg one.
Yeah. In Oranienburg, the local utility provider literally halted all approvals for new charging infrastructure. They had to tell commercial businesses that they were legally barred from installing EV chargers
Wow.
because the upstream high-voltage grid was entirely exhausted. It just couldn't handle it.
See, I have to push back here. Wait, so we're spending billions building all these sleek electric vans, but cities literally can't plug them in without melting the grid? That seems like a massive oversight.
Well, this raises an important question. How do you actually deliver a massive surge of power from a fundamentally weak grid? Because, expanding the grid requires years of civil engineering, trenching up asphalt, and millions in high voltage upgrades. So how do you charge a fleet today?
Right. So what's the workaround?
The industry's answer is battery buffered charging. ADS Tech Energy engineered a system called the Charge Post to solve this exact physics problem. Instead of plugging a fast charger directly into a weak commercial grid connection, they placed this unit, which has a tiny physical footprint of less than 2 square meters, right between the grid and the vehicle.
I love the mechanics of this. It essentially acts like a water tower for electricity.
Exactly.
Like if you want to fill a massive swimming pool instantly, but you only have a garden hose, you just can't do it. But if you let that garden hose slowly fill a water tower 24 hours a day, you can then open the floodgates and fill the pool in seconds.
That is the perfect analogy. The charge post siphons a slow, steady trickle of low-voltage power from the weak grid all day and night, storing it in its internal battery.
So it doesn't overload anything.
Right. It completely insulates the city's infrastructure from the charging spike. When a Bright Drop van pulls up needing a 300-kilowatt ultra-fast charge, the charge post doesn't ask the grid for a single extra amp. It just blasts the energy it has already accumulated directly into the van.
That is so smart. The utility company just sees a flat, predictable draw, and the logistics company gets a fully charged van in 20 minutes without laying a single new high-voltage cable.
And they even utilize the physical real estate of the unit by putting 75-inch advertising displays on the side to generate ad revenue while it buffers power.
That's brilliant. But here's where it gets really interesting, though, because buffering the grid only works if the delivery van actually drives to the charger. But if expanding the grid takes too long and driving out of your way to find a buffered charger wastes too much time, the logistical ecosystem adapts by severing the cord entirely.
Yep. The gas station itself has to become mobile.
We're entering the era of mobile energy on demand. Paying a commercial driver to navigate through traffic, wait in line at a retail fuel pump, and then drive back to their delivery route that's a massive operational leak. ESFIL, which operates in the mobile fuel market, refers to these as deadhead miles.
Deadhead miles. It is the perfect term for wasted momentum. The sources point out that with diesel hitting $5.67 a gallon in places like Florida, every single mile your driver deviates from their route to find a pump is burning expensive fuel while wasting expensive labor.
Yeah, this is actually one of the hidden reasons why the cost of overnight shipping hasn't completely skyrocketed for consumers,
Yeah.
Logistics companies are ruthlessly eliminating this waste. Esfill's model is super simple. Fleet operators park their trucks in their own yard at night. Then Esfill's smart tankers come to the yard and top off every single vehicle while the drivers are sleeping.
No lost route time, zero deadhead miles. And we're seeing that exact same mobile philosophy applied to the electric vehicle transition now.
Oh, really?
Yeah, companies like SparkCharge have developed mobile battery trailers. These units hold up to 500 kilowatt hours of stored energy and can deliver 125 kilowatts of DC fast charging. You just attach it to a standard tow hitch and drop it wherever the demand is.
Okay, but isn't wheeling a giant battery around a parking lot just treating the symptom of a bad grid rather than curing the disease? I mean, shouldn't the ultimate goal be to just pour the concrete, lay the high voltage lines, and hardwire every parking spot?
See, that assumes logistical demands are static, which they just aren't. Concrete is permanent. If you spend $3 million trenching and electrifying a specific warehouse parking lot, and then 2 years later your route density shifts to the other side of the city,
You're stuck.
you have millions in stranded assets. Agile infrastructure isn't a band-aid. It is a core feature of a transitional economy. Mobile charging eliminates sunk costs. You can scale instantly based on actual demand today, not some 5-year projection of where vans might be parked tomorrow.
Okay, yeah, that makes sense. You don't build the permanent highway until you see where the traffic actually flows. And the sources detail how this agility isn't just about saving construction costs either. It's actually being used for active energy arbitrage.
Oh, the economics here fundamentally redefine what a parking space is even worth.
ZPME outlines this perfectly. Businesses are turning their static parking lots into highly active power trading hubs.
Right. Consider a mid-sized logistics company with a leased warehouse. They don't have permission from their landlord to dig up the asphalt, so they buy mobile chargers. They plug these chargers into standard low-voltage wall outlets overnight, buying off-peak electricity at a commercial rate of roughly 25 pence per kilowatt hour.
And then the arbitrage happens.
Exactly.
The next morning, they roll those fully loaded mobile batteries out to the lot. They use some of the power for their own vans, but they open the rest up to employees or visitors, and they sell that stored energy at 50 pence per kilowatt hour.
It is a 100% markup on the energy. A single mobile charger delivering 50 kilowatt hours a day generates a clear margin of £12.50 daily. That scales to over £250 a month in net profit per unit, with zero civil engineering required.
Wow.
The sources highlight a company in the Midlands that deployed just 6 of these ZAPME mobile chargers, utilizing off-peak rates, and generated £1,500 a month in revenue. They literally transformed a dead parking lot into a localized energy market.
That is wild. Okay, so we've established that the trucks are now integrated power ecosystems. We've established that the fuel, whether diesel or electricity, is now entirely mobile, buffering against a weak physical grid.
Yeah.
But logistically, how do humans actually orchestrate all this?
They don't, at least not manually.
Right, because you have mobile batteries,
Yeah.
fluctuating time of use energy rates, battery state of charge limits. If a fleet manager tried to track all this on a whiteboard, the entire system would just collapse.
It would be totally impossible. The glue holding this entire logistical web together is predictive intelligence and telematics. This is where the transition away from mechanical parts to software-defined vehicles changes everything. Querent's data gives us a deep dive into how maintenance itself is fundamentally changing.
And the baseline math definitely favors the transition. The total cost of ownership for electric fleets is drastically lower. Kurt notes that EVs require 40% less maintenance. You are looking at roughly 6 cents a mile to maintain an EV, compared to 10 cents a mile for an internal combustion engine.
Which adds up fast across a fleet.
Totally. There are no timing belts to snap, no oil changes, no spark plugs. Even the brake pads last exponentially longer because the electric motor's regenerative braking handles most of the deceleration.
But the absence of mechanical parts means we have to completely abandon calendar-based maintenance. You no longer bring a vehicle into the shop simply because it hit 5,000 miles. Instead, the industry relies on AI-driven predictive maintenance.
It's constantly monitoring everything.
Right. Telemetry data is constantly analyzing the micromechanics of the vehicle.
It sounds like vehicles are evolving from simple metal tools into living organisms that can tap you on the shoulder and tell you they have a headache before they actually get sick.
That's pretty accurate. It's not just a dashboard light turning on when something is already broken. The software is actually analyzing the voltage sag of individual battery cells under load. It measures internal resistance. It identifies a failing cell long before it overheats or strands a driver on the highway.
And enforces the rules too, right?
Exactly. It strictly enforces the new rules of this ecosystem to prevent degradation in the first place. For instance, Quement emphasizes the absolute necessity of maintaining fleet batteries between a 20 and 80% state of charge.
Because 100% is bad for it.
Yeah, constantly pushing a lithium-ion battery to 100% or draining it to zero accelerates dendrite formation inside the cells, which destroys its lifespan. The AI manages these charging thresholds automatically, ensuring the battery chemistry actually outlasts the physical chassis of the van.
The ultimate goal here isn't just saving a few cents on a kilowatt hour, though. The telemetry, the mobile charging, the battery buffering, it all serves one single master: the total elimination of downtime. You fix the truck before it breaks, and you charge the truck before it needs to search for power.
And if we connect this to the bigger picture, all of this connectivity sets the stage for what might be the most radical shift in modern infrastructure, vehicle to grid, or V2G technology.
Oh, this is the good stuff.
This is where the true scale of what a fleet can do comes into focus.
Let's really dig into the nuts and bolts of V2G, because it sounds a bit like science fiction, but the hardware is already here. Bidirectional charging basically means the flow of electricity is no longer a one-way street from the utility to the vehicle. The vehicle can actually push electrons backward.
Right. And to understand how massive this is, you have to look at the hardware. A delivery van stores power as direct current, or DC, but the city's grid operates on alternating current, or AC. With bidirectional technology, advanced inverters either onboard the van or in the charging station itself take that DC power from the vehicle's battery, convert it to AC, perfectly match the phase and frequency of the city's power grid, and physically push the electricity back through the meter.
So imagine a logistics company with 50 electric vans parked overnight. They plug into the grid at 2:00 a.m. when wind power is abundant and electricity is dirt cheap. They fill the vans. But then at 4:00 p.m. the next day, a massive summer heat wave hits the city. Everyone's air conditioning kicks on. The grid operator starts sweating because demand is about to outpace supply, which causes brownouts.
In the old model, the city would have to fire up a highly polluting natural gas peaker plant to handle that surge.
Which is terribly inefficient.
Awful. But in a VDG ecosystem, the grid operator software sends a cloud-based demand response signal to that logistics company's fleet. The 50 parked vans instantly respond. They reverse the flow of power, acting as a massive localized battery, and discharge their stored energy back into the city block exactly when prices are highest.
It's called peak shaving. The fleet operators literally get paid by the utility company to stabilize the neighborhood grid. The delivery vans are no longer just transportation assets. They've become virtual power plants.
They transition from being a passive drain on the city's infrastructure to an active, stabilizing node. When you aggregate hundreds of thousands of these vans across a metropolis, you completely rewrite the economics of both logistics and public utilities.
So what does this all mean for you, the listener? Why does the specific phase matching of a bidirectional inverter or the internal battery of an ADS Tech charge post actually matter to your daily life?
It affects everything.
It really does. Because this
It's the reason your local power grid can stay resilient during extreme weather events without building new coal plants. And crucially, it is the exact mechanism driving the measurable improvement in the air quality of your city's downtown core.
we have transitioned out of the era of bolting clunky, heavy tools onto diesel trucks. We are looking at a world of mobile power platforms, decoupled entirely from traditional gas stations, buffered against the physical limits of the electrical grid, and orchestrated down to the cellular level by predictive AI.
It's a huge leap forward.
It's absolute revolution happening right under our noses, cleverly disguised as a standard Amazon or FedEx van just pulling into your neighborhood. We want to thank you for joining us on this deep dive into the sources today. Always keep questioning the invisible systems operating around you.
And consider this to take with you. As every delivery van, service truck, and mobile charging trailer is rapidly converted into a bidirectional cloud-connected battery, what happens in the near future when your city's biggest, most reliable power plant isn't a massive concrete building spewing exhaust into the sky, but million parked trucks silently powering our homes while we sleep?